All right, we're going to go ahead and check out this problem right here, solving money denominational problems. So Otis Taylor has a box of coins, and he uses, when he plays poker with his friends, the box currently has 44 coins, which consists of pennies, dimes, and quarters. The number of pennies is equal to the number of dimes, and the total value is $4.37. How many of each denomination of coin does he have in the box? So we have a combination of pennies, dimes, and quarters. All right, and so we will be using this logic right here, and that is that the number of monetary units of the same kind multiplied by the denomination is the total money, right? So if I have 30 dimes, I multiply that by 0.10 because that's the decimal version of 10 cents. You multiply those together and I get $3. Or if I have 15 $5 bills, then I take $5 and then I multiply that by 15. So whatever the denomination is, if it's pennies 0.01, quarters 0.25, you just gotta make sure that that's consistent right there. All right, so these are I guess very similar with the percentage problems, the mixture problems, where normally we can use a table to actually help us out here. So we're gonna go ahead and create another table here. And how this is going to help us, we'll see that right here. Alright, so let's see if we can get this guy cracking right here. Fix that guy. Alright, so let's go back up to here and let's see if we can make some sense of this. And what we're going to do is that we're going to, this column will be the number of coins. This column will be our denomination. Basically, I'm just actually using this. So this is the number of coins, which is right here, denomination, and then the total money. The money value. Okay. So let's check this out here. So the box currently has 44 coins. Okay, so we'll have to come to the total later on. So the denominations, well, some have pennies, so 0.01, some have dimes, 0.10, and some have quarters, 0.25. So there's some kind of number of pennies, of dimes, and of quarters. And if I add up all the coins, I'm going to have 44 coins. So I'm going to put that right here. I'm going to have a total of 44 coins after I add up all the coins for the pennies, dimes, and quarters. All right. Now the number of pennies is equal to the number of dimes. Well, if these two are both equal, then what we can do is that we can not lex. So let's go ahead and let x equal the number of pennies. Okay, so if this is x, then that means that the dimes must be x as well, because it says that the number of pennies is going to be equal to the number of dimes. Okay, and we know that the total value, when you add up all the money values, it's going to be $4.37. So $4.37. Okay, so let's check this out right here then. Let's just see if we can get this guy right here. So if we know that there's a total of 44 coins, there are 44 coins all together, and we know this is x, this is x, then wouldn't this make sense that this right here is 44 minus 2x? You say, no dude, actually that doesn't make sense. This is how I figured that out there. Is that say if actually this was 2 and this was 2. Let's just say, for example, if I want to figure this out, wouldn't you do 44 minus 2 plus 2 is 4, right? I mean, like, you would take these two values, you would take their sum, and then I'll subtract that from 44, because the total is 44, and then I'm going to subtract my pennies and dimes, and whatever's left is going to give my quarters, right? So there'd be 40. There would be 40 quarters if there really was 2 pennies and 2 dimes. But there's not 2 and 2. That's x and x. So that means I added x plus x is 2x, and so I did 44 minus 2x. So hopefully maybe that made a little more sense right there. Okay, so we know how to get this guy over here, which is by multiplying. So we're going to go and multiply x times 0.01, so which is 0.01x. 0.1 times x is 0.10x, and 0.25 times 44 minus 2x. Okay, and there's no denominations here, so we're just saying that there's 44 altogether, and here's the total of $4.37. So would it make sense if you add up the total value of the pennies, the money value of the dimes, money value of the quarters, add all 3 of those up, that you would get $4.37? All right, so that's how we're going to create our mathematical equation then. We're going to take our money value of our pennies, so 0.01x, plus our money value of our dimes, 0.10x. Hold on there. Computer's acting all crazy. Plus our quarter monetary value, so 0.25 times 44 minus 2x, and that's going to give us a whopping $4.37. Like a long equation right there, but we got to solve this guy. All right. And then another commonality with all these types of problems is that normally you're going to be able to multiply both sides by 10 or 100 or something like that. So notice that I can move this over twice, 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 and twice, which means that now we're going to have the decimal is going to be gone then. So I can move the decimal over by basically multiplying the entire left side by 100, and I'm going to multiply the right side by 100. And the shortcut, which is multiplying by 100, is moving all the decimals over twice. So now 0.01x becomes 1x, or just x. 0.10x becomes 10x. Again, I move it 1, 2. 1, 2. 0.25 becomes 25 times 44 minus 2x. And 2 over is 437. Okay. So now let's go ahead and solve this guy here. I'm going to combine these guys and get 11x. I'm going to now do the distributive property. 25 times 44 will give me 1100. And 25 times negative 2x is negative 50x. 11x minus 50x, negative 39x, and then I add the 1100 equals 437. I subtract the 1100. I get negative 39x equals negative 663, and then I divide by 39. X equals 17. Okay, don't stop there and start giving hand claps. Not quite yet. Let's come back up here. So we got x equals 17, so I'm going to write this right here. And let's go back. What was the context of the problem, and what is it that we're actually answering here? It says how many of each denomination of each coin do we have in the box? Okay, so like how many of each denomination. So we're not actually interested in the amount of money. We want to know how many pennies, how many dimes, and how many quarters. So that can actually be solved very easily, because since x is 17, that means I have 17. Let me change my color there. I know I'm going to have 17 pennies, right? If I plug in 17 right here. Well, that means that this must be 17 too, because they're both x. That means I have 17 dimes. And if I want to figure out how many quarters, I'm going to go ahead and plug x in for 17. So 44 minus 2 times 17 was actually just 10. So 10 quarters. So we have it right there. We have 17 pennies, 17 dimes, and 10 quarters.